Hello! Today we are going to take a look at evaluating functions and expressions. All this requires is plugging in different values for variables and simplifying. Let's start with a super simple example. Let's evaluate the function f of x equals 3x minus 7 at x equals 6. To solve, start by plugging in 6 anywhere you see an x. So we see an x right here and right here. So we're going to do f of 6 equals 3 times 6 minus 7. Using parentheses helps you keep the operation straight. We know that we need to multiply these two numbers. So here we have 3 times 6 minus 7. Now, we were asked to evaluate the function at x equals 6. When written in function notation like this, all we need to do is solve for f of 6. So we just need to simplify the right side of this equation. So let's start by multiplying 3 and 6. 3 times 6 equals 18, and then we'll leave the minus 7. Now we can subtract 18 minus 7. 18 minus 7 is 11, so f of 6 is equal to 11. Let's try another one. Evaluate the function g of x equals 2x squared plus 4x plus 1 at x equals negative 3. Don't let the g of x confuse you. Treat it just like you would if there were an f of x. Since we are evaluating at x equals negative 3, solve for g of negative 3. So we're going to start by plugging in a negative 3 anywhere we see an x. So we see an x right here, so we plugged in negative 3. And then we have 2 times negative 3 squared plus 4 times negative 3 plus 1. Notice how important our parentheses are in our first term, 2 times negative 3 squared. If we didn't have them, it would look like 2 minus 3 squared. You would mistakenly subtract a positive number squared instead of multiplying by a negative number squared. So the parentheses are really important to keep our numbers straight. So now that we've properly plugged in our values for x, let's simplify the expression by following the order of operations. So first we're going to simplify the exponents. So we have 2 times negative 3 squared is 9, plus 4 times negative 3 plus 1. Now we're going to multiply. 2 times 9 is 18. 4 times negative 3 is negative 12, so we'll have 18 minus 12 plus 1. And then finally, we're going to add and subtract. So 18 minus 12 is 6, plus 1 is 7. So g of negative 3 is equal to 7. We've taken a look at evaluating functions, and now let's take a look at evaluating expressions. In questions like these, we will follow the same steps we have been. The only difference is there will be more variables. Let's try a problem. Simplify the expression 2x plus 3y over z when x equals negative 4, y equals 8, and z equals negative 2. So first, we're going to plug in the given values for x, y, and z. Make sure to use your parentheses. So we have 2 times x, which is negative 4, plus 3 times y, which is 8, over z, which is negative 2. Now, simplify the expression. We'll start by simplifying the numerator. First, we're going to multiply. 2 times negative 4 is negative 8. And 3 times 8 is 24. So plus 24 over negative 2. It's okay that we drop the parentheses right here in the denominator because negative 2 is the only term there. So now we're going to add negative 8 and 24. Negative 8 plus 24 is equal to 16 over negative 2. Remember, a fraction bar means division. So 16 divided by negative 2 is negative 8. That's not too hard. Let's try one last example together. Simplify the expression 2a over b minus 4c plus d when a equals 9 B equals 3, C equals -7, and D equals 4. So we're going to start by substituting in our numbers. So we have 2 times A, and A is equal to 9, over B, which is equal to 3, minus 4 times C, which is -7, plus D, which is 4. Now we're going to simplify our expression. We're going to start by multiplying. So 2 times 9 is 18 over 3. -4 times -7 is positive 28. So we're going to do plus 28 plus 4. Now we're going to divide 18 divided by 3. I'm going to write that over here. 18 divided by 3 is 6, plus 28 plus 4. And finally, we simply add these three numbers and we'll get 38, which is our final answer. I hope that this video helped you better understand how to evaluate functions and expressions. Thanks for watching and happy studying!